This is the second video on step 3 of hypothesis testing, and it covers the second method of finding or determining if the test statistic is an unusual value. This method is called the p-value method, and again, we're going to talk about the what and the why of doing this using the p-value approach, and we'll leave the how, we'll reserve that till we talk about the individual hypothesis tests. We can then talk about tables that are used and the calculator functions that we may use for it. So let's get started here, and we will talk about the p-value approach. Okay, so first of all, we need a definition of p-value, which would be a good one to keep in your mind. A p-value is the probability. Now notice it is a probability. It is an area underneath the curve, an area underneath the test statistic function curve, an area underneath the density function. P-value is the probability of observing a value of the test statistic that is more extreme, which means farther from the mean than the test statistic value that was actually observed, the one that was calculated in step 2. There are two things that we need here. We need to have in hand the test statistic value that we found, our observed value, and we also need to know what the relationship is in the alternate hypothesis, H1. So with those two in hand, we're going to look and see what the options are for finding p-value depending upon what the relationship is. Left tail, right tail, or two tail. If the relationship in H1 is less than, we're going to we're going to plot the test statistic, and because it's less than, we would anticipate that the test statistic is less than the mean. So it would be a good idea to draw a picture again, just like we did for the the critical value approach. And the picture is very similar in terms of the horizontal line being all the values of the test statistic. We plot the mean on there. We also plot the test statistic on there. And the curved line, where the peak of the curve is directly or is above or nearby above the mean. And when we plot this test statistic for finding p-value, what we're going to do is find the area underneath the curve, because we're talking about probability, find the area underneath the curve farther away from the mean than the given or computed test statistic. And for a left-tailed test, it's one tail. Therefore, this p-value is this area that we find underneath the curve. Okay, let's look then at, and by the way, the methods for finding p-value are listed here. You don't have to worry about those at this point in time, because we will be discussing these when we talk about the individual hypothesis tests. Okay. Now let's look at the situation when H1 is not equal. It's a two-tailed test, okay? Which means that when we talk about the probability of finding test statistic values more extreme, meaning farther away from the mean than the given computed test statistic, if we talk about the distance from the mean that the test statistic is, farther away from the mean could also mean on the other side as well. In other words, if we are talking about a test statistic being on the left, we would find that area underneath the curve farther away from the mean to the left. But we would also find the area underneath the curve farther away from the mean, same distance from the mean on the right, okay? Because it's a two-tailed test. And so what we'll do is, wherever the test statistic is, If it's on the left, we'll find the area underneath the curve to the left, farther from the mean than the test statistic, and we'll multiply that by 2 to get the p-value. If it's two-tailed, you plot the test statistic, you find the area farther away from the mean, that is, for two-tailed, that is not the p-value. We have to multiply it by 2. You have to remember that. You're finding an area farther from the plotted mean, plotted computed test statistic, than farther from the mean than the test statistic, and we have to multiply it by 2 for a two-tailed test, okay? Then if the test statistic happens to fall on the right instead, we will plot the test statistic to the right of the mean, and we will find the area underneath the curve farther to the right than the test statistic. And that will be, and we'll take that area right there and multiply it by 2 to get the p-value because it is two-tailed. And if the test statistic happens to be, if the alternate hypothesis relationship is greater than, that means the test statistic most likely is a value that is larger than the mean. And we're going to plot the test statistic wherever it is to the right of the mean, and we'll find the area underneath the curve to the right of the test statistic. Values of the test statistic that are farther away, more extreme than this test statistic, farther away from the mean than the test statistic. And that will be the p-value because it is a one-tailed test. That's the methodology for finding the p-value. How we do that, though, depends upon what parameter is being tested, okay? And again, we've got those things listed here for each one of these situations, but we'll reserve discussing those to a later video when we talk about the individual hypothesis tests, okay? And we'll talk about the use of tables and the use of functions on the calculator. All right, so now that we know what we're doing here for finding p-value, let's go look at the problems that we did. And I'm going to stop sharing and we're going to go switch over. This, and we'll share this. All right, here we are in our 6 problems. Claim everything's been done in step 1, everything's been done in step 2. We'll ignore the critical value approach because we've already talked about that. And let's talk about the p-value approach. So like I said, you need 2 things. You need to know what the test statistic value is. So we've got test statistic value, it's t, we're testing the mean. Test statistic value is t. This is negative 0.480. So we would plot that underneath the curve along the test statistic values. We'll plot our negative 0.48. It's a left-tailed test because the alternate hypothesis is less than, and that means we're going to find the area underneath the curve farther away from the mean than the test statistic. So to the left of the test statistic, we find that area underneath the curve, and as it turns out, the area underneath the curve is 0.3180. Okay, that is our p-value. And what we're going to end up doing is comparing the p-value to alpha, okay? And when we do that, we will decide that the computed test statistic is unlikely if the p-value, that area underneath the curve that we found, if that 0.3180 is less than alpha, then we will say that the test statistic value is unlikely. Okay, so alpha is 0.05, and we'll make the decision in the next video, once we have that p-value, we'll be comparing it to alpha, and we will discuss how we reject based on that. So we'll be comparing the p-value to alpha to make our decision. Okay, that's the first one. Second one, this one is a test of standard deviation. And we know what the test statistic is. It is 72. And this is a chi-squared curve. So what we're going to do is plot the test statistic. Remember, chi-squared starts at 0, and the mean is a sample size minus 1. So right about in the middle here, we would plot that mean. And then we plot 72. And this is why we do the plot, because we know we have a point of reference to know whether our test statistic is to the right of the mean or to the left of the mean. So once we've got that plotted, we're going to, because it is a right-tailed test, we're going to be shading in underneath the curve farther from the mean than the test statistic. So we're shading in underneath the curve to the right of 72. And since this is a one-tailed test, that area that we find is the p-value. And the area is 0.0224 in this case. And now we would compare that to alpha. Well, alpha is 0.01. This is bigger than 0.01. In order for us to say that the the test statistic value that we calculated is unusual or unlikely, it would have to be less, this probability, the p-value would have to be less than or equal to alpha. This is greater than. So our test statistic value is not unlikely in this case, okay? And again, let me just repeat that. This is important to keep in mind and to remember. You have to remember this. If you're using the p-value approach, if you have a p-value and you know what alpha is, you will make your decision as you will determine if a test statistic is unlikely by comparing the p-value to alpha. And you will say it is unlikely if the p-value is less than or equal to alpha. Okay, so let's go look at the next one. Again, this is also a test of standard deviation, and alpha was 0.05. And it's greater than, again, the alternate hypothesis says greater than, so it's a right-tailed test. And so what we need to do then is we'll sketch our critical value, not critical value, we'll sketch our chi-squared distribution here. Starts at 0. The mean we would plot is right around where this peak is. We draw a curve up. And by the way, when we're drawing a curve for chi-squared, it starts slow, comes up to a peak, and then goes down slower. In other words, it is stretched out on the right. And when it's stretched out on the right, we mean that implies that it is skewed to the right. Okay. All right, so we plot our test statistic. 36.507 was the test statistic value. We plot that. It's to the right of the mean because it's a right-tailed test. And we find the area underneath the curve farther from the mean than the test statistic value. That area underneath the curve is alpha because it's a one-tailed test. And we find in this case that the area underneath the curve is 0.0490. Okay, so that is our p-value. Now, what do? We need to compare the p-value to alpha. Alpha was 0.05. We compare 0.0490 to 0.05. And as it turns out, it is smaller than 0.05. P-value is less than alpha. Therefore, we can say that the test statistic is unlikely. Okay? And now let's go to the next one. Again, alpha is 0.05, and the alternate hypothesis is not equal, making it a two-tailed test. Our test statistic is t equals -4.733. So what we would do, and this is a rather trivial case for p-value, but what we would do is draw draw the picture of the, in this case, it's t, the t distribution, mean is 0, and we plot the test statistic. It's on the left, negative 4.733. It's way out here, okay? And we find the area underneath the curve farther from the mean than the test statistic. So way out here, area underneath the curve, way out here. And that's going to be very small. And because this is a two-tailed test, once we find the area farther from the curve than the test statistic, we have to multiply it by 2. And 2 times 0 is 0, okay? It's not really 0, but to 4 decimal places, it is, okay? So and then we compare the p-value, which is 0, to alpha, and it certainly is less than or equal to 0.05, which means that our test statistic value is unlikely. And so let's look at this the next one. This is a test of proportion. Alpha is 0.05. The alternate hypothesis is less than. And we know that this is a left-tailed test. And so what we're going to do is plot the test statistic. First, we draw our curve. Horizontal axis is for values of the test statistic. The mean is 0 of the test statistics. We plot the calculated test statistic, which is to the left, negative 1.46. Left-tailed test, we're going to find the area underneath the curve farther from the mean than the test statistic. So from negative infinity up to negative 1.46, we're finding that area. That is the p-value, and we find it to be 0.0721. So, and we would remember to determine if our test statistic is unusual, we compare that to alpha. 0.0721 is bigger than 0.05. So our test statistic is not an unusual value. Remember, for it to be unusual, it has to be less than or equal to alpha. Again, you need to remember that. Okay, finally, the last problem. Again, it's another test of proportion. The significance level is alpha, and H1 is not equals, making this a two-tailed test. And our test statistic was found to be z equals negative 2.19. We plot the curve for z. The point of reference is the mean in the middle, that's 0. And wherever the test statistic is, on the left or on the right, we will be plotting it, no matter what it is. We plot it, and because it's a two-tailed test, we will find the area underneath the curve farther from the mean. In the depending on the side it's on, we'll find it the area underneath the curve farther from the mean than the test statistic. So because it's on the left, we'll find the area to the left. If it were on the right, we would find the area on the right, or to the right. So we find the area to the left of negative 2.19, and that is 0.0143. But that's not the p-value, because this is a two-tailed test. So we are going to multiply that by 2 to get 0.0286, and that is the p-value. After we multiplied by 2, because it's a two-tailed test, we have the p-value. And to determine if the p-value, or if the test statistic is unlikely, we compare this to alpha, the p-value to alpha, and it is less than 0.0286 is less than 0.05. Therefore, we can say that the test statistic that we computed is unlikely. And that concludes our discussion of the p-value approach. Again, we'll talk about the how in a subsequent video.